All right, today we are talking about counting atoms. So counting atoms of elements within a compound, normally within a compound. In your warm-up, you went over the difference between a compound and an element. An element is one element from the periodic table. So hydrogen would be an element. But when you are talking about something like water, H2O, that's a compound. It's more than one element combined together. You can tell the difference between an element and a compound because an element will only have one capital letter. A compound will have more than one capital letter. So let's start with our first example. So example 1. And I'm going to show you that without even being taught how to do this, y'all can already do this. I bet. Our first example is going to be H2O, water. So we have two capital letters, capital H, capital O. So let's first make sure that we identify that we have a compound made of hydrogen and oxygen. Now, I'm curious if you can figure out how many atoms of hydrogen we have and how many atoms of oxygen we have. So, you're looking at this. You see a 2 next to the H. So how many atoms of hydrogen do you think we have? If you thought 2 atoms, you are correct. Next to the O, you see nothing. So how many atoms of oxygen do we have? Now, maybe that's a little trickier. So we're going to write a special star, a special rule here. And for that rule, we are going to say, if there is no subscript, then you add a 1. So a subscript is this little number. When in math class y'all do something squared, that's a superscript. It's the number that's on top. Since our number is below, it's a subscript. This little number is a subscript. If there isn't a subscript next to that element, then you have to add a 1. It's your job to write a 1. The reason they don't write a 1 is because it's assumed. It's assumed that if there's no number, there is 1. So we only have 1 atom of oxygen. So every element in the compound has a subscript. It's just that the 1 won't be written there, but it's assumed that there is a 1. And so you just count the numbers next to that element. Let's try another one. Example 2. All right, for this example, we are going to do CH4. CH4. All right, so let's label first that this is a subscript. So that small number is a subscript, and it is equal to the number of atoms. Now let's go through the steps to follow this, or the rules, or I should say the rules to complete this problem. For this example, our question would ask how many atoms are in this compound. There are some rules for calculating our answer. Rule number 1. add ones if there's no, oops, that's a big A. Add ones if there's no, and I'm writing this short. I know it's not proper. Add ones if there's no subscript. So if there's no subscript, we need to add a 1. In this compound, do we need to add any ones? How do I know C and H aren't one element on the periodic table? How do I know it's not talking about CH on the periodic table? There are 2 capital letters. They are both capital, so they are 2 separate elements, carbon and hydrogen. So I need to give C a 1. C doesn't have a 1 hanging next to it. All right, rule number 2. Draw arrows if there's parentheses. Draw arrows if there are parentheses. Now, we haven't looked at parentheses yet, so you don't know what I'm talking about. So let's ignore that rule for this moment. Write it down, ignore it for a moment. Rule number 3. Make E a chart. All right, so in science, instead of saying, y'all watch ESPN, it always says EA Sports. It's in the game. In science, we say, oh, what am I trying to say? We say EA chart. It's in the name. So our answer is in the compound. It's right there. Our answer's there. We just need to make an EA chart. So E stands for elements. A stands for atoms. So you just make a simple T-chart with an E and an A. On this side, we list the elements. On this side, we list the atoms. So we have element C, carbon, element H, hydrogen. So you just list the elements that are in that compound. Now we list the atoms of each element. So for carbon, we have 1 atom. For hydrogen, we have 4 atoms. And then we always have to put the total. That's really important. So total atoms in this compound, 1 plus 4 gives us 5. 5 total. I know with confidence that all of you can count these little numbers, it's called subscripts, add them together, find the total atoms. Easy peasy. The last step, when we add in parentheses, gets a little trickier. We got a little trick here. So I'm going to title this section parentheses. When we add those parentheses in, I'm not going to lie, it gets a little bit tricky. It's no big deal. Make it easy. All right, let's write a rule, special rule, or not a rule. Let's write a special important thing you must know. I'm going to give it another star. If there are parentheses, you must multiply. There are parentheses, you must multiply. So, example 3. This compound's going to be a bit longer. We are going to do Al2, SO4, 3. So I have parentheses in this one. It's looking a little different, but no big deal. It's easy. I made it easy because we're going to follow our rules. Rule number 1, if there's no subscript, you have to add ones. AL has a subscript. Don't get tricked. That is A lowercase l. That's aluminum. A doesn't need its own subscript because it's part of aluminum. So Al gets a subscript of 2. What about everything else? S doesn't have a subscript. Have to add a 1. O has a subscript 4. We're good. All right. Rule number 2. Draw arrows if there are parentheses. So let me show you what that means. We are drawing arrows to distribute.
Teachers, please.
All right, we are drawing arrows to show we are distributing. You've used that word in math class. The 3 is being distributed to the 4 and being distributed to the 1. An arrow means you multiply. When you see an arrow, you must multiply. But we're still following our same steps. We did rule 1, we did rule 2. Let's do rule number 3. Let's make our EA chart. Okay, let's list our elements. How many elements does this compound have? 1 Al, 2 S, 3 O, oxygen. Now, let's fill in the atoms. Al is not in the parentheses. We didn't draw arrows, so we have 2 atoms of Al. We just look at the subscript. S is in parentheses. It does have an arrow, so we have to multiply. 1 arrow is a times sign, a multiply. 1 times 3. 1 times 3 equals 3. 4 is in parentheses. It has an arrow, so 4 times 3 equals 12. All right, am I done? Are we good to go? No, part of our EA chart is putting our total. So I'm adding 2 plus 3 plus 12. That gives me 17. So every time that you are counting atoms, you follow these 3 rules and it'll be easy. Easy peasy. Don't forget that a lowercase letter goes with the uppercase letter. It's one element. Each new element has an uppercase letter. If there's no subscript next to it, give it a 1. Everybody needs some subscript. All right.